Hello everyone, let's get started with lecture 3. So here we go. Today's lecture, we first examine soft skills, the importance of leadership, management, conflict, maybe a bit about negotiation. But here's the thing, for so many years project management was considered something that required primarily hard skills, analysis skills, the creation of schedules, for example. But it's increasingly recognized that leadership and management is also important. So let's examine this first before we get into the more analytical content today. Leadership and management. What does the PMBOK say about this? The PMBOK describes responsibilities, competencies, interpersonal skills, the importance of communication and stakeholders. And you could ask, what is a stakeholder? A stakeholder is anyone who has an interest in the outcome of the project. So there's a lot of interpersonal skills required for interacting with people inside and outside the project. The client, the sponsor, the team members, members of other departments. This requires human skills. Not every project manager has this. And in fact, the Project Management Institute has developed something called the Talent Triangle. And the Talent Triangle states that there's 3 major components to project management skills. There's strategic, there's technical, and then there's the human skills. An ideal project manager has all 3. So let's take a closer look. I think we have already acknowledged in many of our assignments that leadership points the way. They say that leaders do the right things, whereas managers do things right, which means the leader of the project points everyone in the right direction, and then the managers supporting the leader efficiently implement the direction that the leader has pointed out. And as a former instructor of mine once said, leaders in the organization have the responsibility of vision, seeing ahead, seeing competitive opportunities. Therefore, leaders must wear a different set of glasses than the rest of the organization. They should be able to understand the competitive landscape. And I think that's an interesting way to think of it. Okay, so leaders versus managers, but they work together. You know, there's exchange of purpose. Managers have a right to say no. Leaders and managers have joint accountability, and they're honest with each other. You can't have one without the other. You can only take your organization so far by pointing the way. There must be an interaction between both leaders and managers to not only go in the right direction, but to produce results. So we see the differences, and I think you're all aware of this, as I've seen evidence of in the assignments. Are you a leader, or are you a manager, or are you a combination of both? It's a good question, and in fact, there is so much theory out there about leadership. All I can say is there is no single formula for how to be a leader. All I can say is that if you see a leader, then that's leadership. If you see them producing results and actually leading. But then again, leaders come in all shapes and sizes and viewpoints and use different skill sets. So it's difficult to say, here's what you must do in order to be a good leader. Okay, the project manager needs hard and soft skills. And so we know that leaders have a combination of soft and hard skills, but there's an interesting aspect of leadership in project management. Not only did they acquire resources, motivate and build teams, but one thing to remember is that project managers have people only on a temporary basis. So because of this fact, project leaders have to influence people, they have to encourage people. People have to want to be a part of the project team because the project manager has very little power to order someone to do something. So it's leadership more by influence than by power, which is an interesting aspect of a project team leader. Okay, acquiring resources. This is a difficult job for a project manager. Often projects are underfunded. And one big reason for this is because the goals are unclear. That means poor scope. Maybe they're not getting enough funding from top management. Maybe there's a lack of trust. Requirements are understated. This illustrates the fact that the link between the scope, the schedule, and the budget are closely tied together. So you can appear to be understaffed in terms of, or underfunded, and you could think of this as being strictly a funding problem, but it may not be a funding problem. It could be a failure to identify scope correctly. So the issue here is that scope, schedule, and cost are very closely linked. And because of that, you can't simply say that a funding problem or a resource problem is just about resources. There could be many other factors involved. One thing that a project manager has to do is hold meetings. Personally, I don't like meetings very much. The only reason I think you should have a meeting is because you must share something with a number of people all at once. Otherwise, you could meet with the project manager and individuals separately, one-on-one. No need to waste everyone's time. But if you are going to have a meeting, you have to be very clear about what you're going to do. Maybe you assist team members in understanding their role in the overall project. You revise, update, and add to the knowledge base. This is a list of things that you might do in a meeting, but let me suggest this. If you're going to have a meeting, have a clear purpose, have specific outcomes for the meeting. Once you achieve those objectives, the meeting's over. It's time to do something else. Leaders and project managers, and I would say a project manager should be a leader in many cases, must communicate. Now, when project managers are working with project stakeholders, there are a couple of components to their communication and leadership that should be considered. Task-oriented and group maintenance behaviors. Another way to say this is task versus relationship-oriented. I tend to be very task-oriented over relationship-oriented. Other leaders are more focused on relationships, but task-oriented is focused on getting the work done, making the process clear, clarifying things, making sure everyone's agreed. It's all about getting things done, whereas group maintenance is more about building relationships with the group. Now, both can work. The group maintenance behaviors is really oriented toward focusing first on the strong relationship, and with that in place, perhaps the group can work together to produce results. Others think there's no sense wasting time on building those strong relationships. It's better to make sure everyone knows what to do and when to do it. Both sides have merit, but what many leadership theories tell us is that a good manager has a balanced mix of task-oriented and relationship-oriented or group maintenance behaviors. One thing that a project manager does is address conflict and negotiates with other stakeholders in the organization. This mostly happens during the acquisition of the project team, the development, and the managing of the project team. A project manager has no team from the start. The project manager must acquire team members from other functional groups, and that requires some negotiation. You have to ask the department manager or supervisor for team members, so this requires some negotiation. There's also skills involved in developing the team, and some negotiation could be involved. For example, you may want to assign a certain amount of work to one person in the team. The team member may want to do something else, and it may require some back and forth negotiations. Here's a process flow for assembling a project team. It's very straightforward. It starts by identifying skills and it says from the WBS. Why WBS? The WBS is an outline of what the project will deliver. So once you consider what the project will deliver, then you consider what skills or what activities are required to deliver them, and then you think about what skills are required to complete those activities. Once you have all three, then you can negotiate with department supervisors to find the right person for the job. But when you do have the team together, one of the most important things to consider is the sense of mission. Where are you going and why? I've heard it said that a good leader goes beyond telling someone what to do. An effective leader explains why something should be done. If you understand why, that is having a clear sense of mission, and that helps build trust. If you understand the purpose of what you're doing, that's really important. And if we look at the other side of this, we examined effective project teams. What about ineffective ones? Ineffective teams have unclear goals. Maybe it's unclear who is supposed to do what. The leadership is lacking. Communication is lacking. There's turnover. We've seen this happen before. And the antidote to this is to recognize that teams do not happen overnight. They evolve in stages. These are the 5 stages, and I've mentioned to some of you already that this is a theory about how teams evolve. And theories attempt to explain it, but they don't always explain it perfectly. Reality is always different from a theory. But I think many of us see this as a reasonable model for explaining team behavior. And if you think of team development this way, one thing it tells you is that the team will not be ready to do effective work overnight, that there's going to be some conflict, and you should expect that. That's stage 2 in the 5-stage model. So don't be surprised about conflict, expect it, and work through it. And notice how through the forming, storming, norming, performing, you've got inclusion, control. Maybe it's the fight for the control, and then eventually there's cooperation and productivity emerges from this. So it's an evolutionary process. There is an alternative point of view that says, hey, you don't have these 5 stages. What happens is that the team is brought together. Maybe there's conflict, but then about halfway through, there's the recognition that time will not last forever. They've got to work together, and this has to happen quickly if they want to produce results, and that's when the performance of the team has a step function. That's why it's called punctuated equilibrium. There's a sudden shift upward in performance, and that continues into completion, and that's driven by recognition that there's time constraints and they can't go on fighting for control and dominance forever. How do you have cross-functional cooperation? This is the last topic, and human factors or leadership and management skills in project management. The reason for the term cross-functional is that the project manager is outside of the functional groups of the organization, and the project manager draws resources from those functional groups. Because of that, there has to be collaboration between the project manager and the functional groups. A good way to think about this is when people are assigned to a project manager, the project manager directs the team members what to do and when to do it. But it's the functional manager that decides who will do it and how they will do it. And this is where you get cross-functional cooperation, working together of the project manager and the functional manager. All right, let's shift our discussion now to risk management. It's always difficult for project managers, and there's so much emphasis put on risk identification and brainstorming, because even if you work very hard to identify risk, usually the risk that becomes a problem is the one you fail to identify. That's quite common. So let's examine some risk management concepts. You plan for your risk management, which is what is your strategy for how you will manage risk. Identify the risk, do qualitative and quantitative analysis, consider how you will respond to risk, and control your risk. When you think about risk management, you think first about what might happen in terms of probability, and if it does happen, how bad will it be? what should be done to minimize the probability or impact, and what cues or what triggers will lead me to react to this risk that's emerging. What are the likely outcomes? So risk management is you identify, analyze, and respond to risk factors. And a risk, that's an uncertain event or condition, and its probability of event and the consequences. You may have heard that saying, no risk, no reward. Well, here's one way to explain why this is true. One way to think of a project manager is that a project manager is a risk manager. If you define risk as anything that stands in the way of project success, the project manager is there to ensure that those risks are alleviated in some way. This is rather like an airline pilot. The reason the airline pilot is there is because risks are always present in an airline, even though computerization of airlines lead to possibilities of the airplane flying itself in many cases. But the airline pilot is there to work through the barriers to the flight success, landing in a safe place. Okay, so because there is risk, you need the risk manager. That's the project manager. The project manager earns a salary for doing this job. That's the reward. So if there were no barriers to success, projects would just happen. Things would work out right. But in reality, that never happens. Projects don't just happen automatically. It requires close management through the barriers to success, and that's risk management, and that's what a project manager does, and the project manager gets paid for that. So the project manager is an example of why, if no risk, no reward, there's no opportunity to earn a reward unless you are someone who can work through the barriers to success or risk. Okay, with that explained, let's move on. Notice that risk changes throughout the project. You've got very high opportunity and risk at the beginning of the project because there's so many unknowns. You haven't done much yet. Okay, the opportunity declines, the risk declines as you get toward the end of the project. But notice that the risk impact is very high toward the end of the project. And why is that? Well, if a risk is uncovered late in the project, it's going to be very costly to address that risk or create a risk response. This is why if you identify risk, you need to do it early, because notice the impact of risk is very low early in terms of dollar value or V&D value. You can get that risk addressed early in the project. It costs you less. If you wait too late, the impact of the risk will be quite high and it will be very expensive. So this is why there's so much focus on risk identification. So you identify, you analyze, and mitigate. Mitigation simply means what are you going to do to respond to risk, and then you control it. There's often common types of risk, and this is used in brainstorming. You can think of financial, technical, commercial, execution risk. When you think of clusters of risk, this may help you consider specific risk that could arise in your project. And the risk clusters could help you in brainstorming meetings or perhaps help you in discussions with experts. You may examine past history. You may do some assessments. Now, here is another breakdown structure. So far, you've been exposed to the work breakdown structure, the organizational breakdown structure. Now, here's the risk breakdown structure. What's the difference between the three? The WBS is a structured outline of project deliverables. The OBS is a structured outline of the organization that allows you to illustrate the correspondence between a WBS deliverable and the element of the organization that produces it. The risk breakdown structure, though, is really a brainstorming tool. Here you see internal and external risks, market, environmental impact, technical, organizational. This is just a way to help you think through risk possibilities. It's kind of a risk brainstorming template. Or maybe RBS, risk brainstorming structure. Maybe I invented a new term. Once you've identified the risk, you do the probability and the impact. For example, if the probability is of something happening is 10%, and the impact, if it happens, is $100, probability times impact is 10% of $100 or $10. And then you take, once you've done the probability impact analysis, you can plot them in this probability impact matrix. Here, this is labeled as likelihood consequences, but it's also probability impact. And I often think of this as a PI matrix. The reason you have a plot like this is because a project manager can't monitor everything to the same degree. So you're going to focus higher priority likelihood and consequences or probability impact first. So you will focus your efforts on watching for the upper right-hand corner of this plot. You can also score risk. You can score probability of failure, maturity, complexity, dependency. Maturity is how advanced the technology is, how long it's been around, how complex it is. This is just a way to score risk, and using the team's consensus is just a tool. All of these ways are just ways of methods of producing a risk factor. The higher the factor, the more carefully you need to watch that for that risk. Risk mitigation strategy. Mitigate means things you are going to do to minimize the impact of risk. I tend to think of, well, we have here accept, minimize, share, transfer. I tend to think of the mnemonic device MART. You can mitigate, you can accept, mitigate, accept, retain, or transfer. If you mitigate, you're going to put a plan in place to try and counteract that risk. If you accept it, you're just going to shrug your shoulders and say, well, we have to live with it. You could also use A for avoid. Maybe you don't do some aspect of a project because there's a risk there. So you may avoid the risk. I tend to use mitigate, avoid, retain, because retain and accept are the same thing. And transfer is to give it to someone else or pay someone else to take it. And one way we do this is through insurance. If you have insurance on your motorbike, if there's a wreck, the insurance company, you've paid to transfer the risk to the insurance company, so you will not have to pay. That's an example. Okay, so these are typical strategies for dealing with risk. There's 9 phases of risk assessment. Of course, this is how one textbook would describe it, but there's others that think of it as a different way. But you define the risk, you focus, what are the details, you identify, you structure. I don't know. This comes out of the textbook. Personally, I think this is a little bit vague way to assess risk. Personally, I think you start off by identifying risk. Then you, once you've identified those risks, you analyze the risk in terms of likelihood consequences or probability impact. Then you rank the risk. You put those ranked risks in a risk register and the highest ranking risk. And you also plot them in the probability impact matrix. Those highest ranking risks are the ones that you address first. And for those, you consider MART. Am I going to mitigate? And am I going to avoid? Am I going to retain it? Am I going to transfer it? Or some combination of above? The text kind of lays out a different path, but this is how I view it. Straightforward, step by step. You know, you identify, you assess, you rank, and then go through the MART process. Decide if you're going to mitigate, avoid, retain, or transfer, or MART. One reason I say this is I live in Atlanta, Georgia, and we have in Atlanta a transportation system called MARTA, Metro Atlanta Rapid Transit Association. So I always think of MART as a way to remember risk management. Okay, let's now move to Module 9 and discuss scheduling. I'm going to jump to a different slide here for scheduling. Let's take a look at this definition of project scheduling. Project scheduling, you're laying out some step-by-step sequence. You're going to present a schedule with linked activities, planned dates, durations, milestones, resources. That's in the project schedule. Notice dates, durations, milestones, and resources are on the project schedule, but they're not in the WBS. The WBS has only deliverables. It doesn't have milestones, resources, or durations. That's an important distinction. It doesn't mean that those things aren't important. It's just that they don't go in the WBS. They go in the project schedule. So when we think of scheduling, one of the first things we may think about is network diagrams. Why do we need network diagrams? Just to be clear, and by the way, network diagrams are often produced automatically these days by project management software. But many of you have done them by hand, and that's good. But they're done for one purpose only. You need to see the logical order of project activities, and the reason you need to see this is so you can understand the overall duration of the project from end to end. Let me give you a simple example. Thinking about making coffee. Coffee in Vietnam is pretty good, I think. But if you're going to make coffee and someone says, how long does it take to make coffee? One way you could do it is add up all the durations of each of the activities required to brew coffee. For example, here is activities A through P. You can get coffee grounds, get water, filter, get cup, get cream, get sugar, get spoon, etc. So I've listed these activities in order, and these are in seconds, and I have a duration of 630 seconds. So one way to answer this is to list the activities and add the total duration, and you're done. Well, not really, because you can see some of these activities must happen in order, while others may happen in parallel. Also, some activities are shorter than others and longer than others. So there's some steps you could take to adjust this and to know the duration in better detail. For example, getting the cup, the cream, the sugar, and the spoon. You could do that while the coffee is brewing. DEFG takes 25 seconds, but brewing the coffee takes 500 seconds. So why don't you try doing some of these things in parallel, and that way your schedule won't take as long. Some would say, why don't you go ahead and put cream and sugar in the cup while you're brewing coffee? That's possible, although some people prefer to pour it into the coffee after the coffee is poured. But if you assume M and N don't have to be added after the coffee is poured, those could also be done in parallel. So instead of 630 seconds, we really have 605 seconds and possibly a little bit under 600 seconds. And the reason we know this is because we have organized these in logical order. That's the good news. The bad news is most projects are more complicated than this, and it requires ordering the activities in a little bit more creative way in order to reveal the complex logical relationships between the activities. It's not so simple as a cup of coffee, and that's where the network diagram comes in. Okay, in a network diagram, just like in brewing coffee, there's certain things you must do in order in some cases. For example, you have to put in the filter before you put in the coffee. You put in the coffee in the filter, and then you pour water, and then you brew the coffee. Brewing must happen after you've added coffee, filter, and water, and so on. So some activities are sequential in nature. Others are in parallel, non-sequential. For example, D, F, and E, G in these examples are parallel activities. Just like in brewing coffee, I could go get cream, sugar, cup, etc. And I could do that in parallel with coffee brewing, and that compresses the overall end-to-end duration. And what I've just shown you is a network diagram. It's a schematic display of logical relationships. That's an important phrase to learn. Logical relationship of project activities. A path is a sequence of activities. An event is a point where an activity is started and completed. And a node is a junction point. Okay, now you will see a number of scheduling terms that may be a little bit complicated at first, but you get familiar with it at practice. Predecessors. Predecessors simply means things which come before. Successors are things that come after. For example, adding coffee to the filter and adding water to the coffee pot is a predecessor to brewing coffee. Pouring coffee is a successor to brewing coffee. The early start and the late start, that's the earliest possible time an activity can start and the latest possible time. Here's an example. We mentioned brewing coffee, and brewing coffee took 500 seconds. If getting your spoon, the cup, sugar, I believe we said that those took about 25 seconds. So if you were going to do those in parallel without delaying the schedule, what's the latest you could start them? If brewing coffee was 500 seconds, then you could start collecting the spoon, the cup, the saucer, the cream, the sugar. It may be 475 seconds. So you could delay that till just the last part of coffee brewing, and you still wouldn't delay the schedule. That's how late start is determined. It looks at how much slack is in the schedule. In the case of coffee brewing, it's the brewing portion. And once you know that, then it tells you the latest you can start certain activities. Okay, we use a technique called forward and backward pass to determine what's the longest path in the project. And I'm going to jump to something here. I'm going to go back to a slide we just saw. This slide, we know that there are two paths in this project, ABC, DFH, and ABC, EGH, which is longest. Well, to determine that, the longest, by the way, is going to be known as the critical path. It doesn't mean that those are absolutely the most important activities in the project. There could be other activities, but critical path means these are activities that cannot be delayed without delaying the overall project. So we know we've got two possible paths here, and we need to know which of these paths is the longest. We do this by putting in the durations, and then we do an algorithm called the forward and backward pass. The forward and backward pass reveals or will reveal which of these paths has slack in it and which does not. And in doing so, you may refer to a merge or a burst activity. For example, activity H is known as a merge activity because F and G merge into it. C, on the other hand, is known as a burst activity because D and E both exit from activity C. Float, another way of saying float is slack. The amount of time an activity may be delayed without delaying the finish of the project. In the case of coffee brewing, if coffee brewing took 500 seconds and getting your cup, spoon, sugar, saucer was 25 seconds, then you'd have 475 seconds of float. Now, you should also know that there's different ways to do network diagrams. Activity on arrow versus activity on node. When I'm actually there for a series of seminars, I will show you why activity on arrow is used. But in normal project management, most humans use activity on node. And the reason you might use activity on arrow is activity on arrow or activity on arc. This type of network diagram style works better with computerized optimization programs. So if you're using computerized techniques to try and optimize your project, you may use activity on arrow. Otherwise, you will generally favor activity on node. When you do have activity on node, you typically have the activity description in the center, the duration at the bottom, the early start, activity duration, and early finish. So for example, a typical activity, let's assume this took 10 days, and this is the first activity in the project. You may have a 0 by the early start, 10 activity duration, and early finish would be 10, for example. Okay, and again, we have serial activities, ones that flow from another, and concurrent activities if we've seen. And again, here are examples of merge and burst activities. And here's a complete activity network. Now, this is why I told you network diagrams are needed, but they're not always needed for making coffee. And the reason is, by inspection, even if you have the durations listed for each of these, it would not be easy to determine which of these paths are the longest. That's why you need to have a network diagram in place so you could calculate which path is the longest. So now let's look at an actual diagram with some durations in place. Okay, here's an activity with a forward pass. Some of you have already done this, but how it works is you start from the beginning. Contract A, you go from 0, the duration of 5, and you end at 5. When you have two activities following a burst activity, in this case, you carry over the finish to the early start. Okay, so B and C start at the same time. B is a duration of 5, C is a duration of 6. One ends at 10, one ends at 11. Now in the case of a forward pass and you have a merge activity, you have multiple activities merging into another, the duration you include in your merge activity is the longest of the activities. So activity C finishes later than activity B, so D begins with 11. Now you might ask, why should this be? There's a simple reason for this, and in the diagram you can see that activity D can't start until B and C are finished. So what time would B and C both be finished? Well, they're both finished when C is finished. So that's the longest time. So this is why D can't start until 11, because according to the logical flow here, D cannot start until B and C is finished. Okay? We see this also further down where we have activity H and we have 3 activities merging into it. Notice that activity H begins on day 28 or time period 28. Why? Because H cannot start unless E, F, and G are all finished. And at what time will they all be finished? At time 28, which is why 28 starts here. So this shows an end date of 30. Now, to determine the critical path, we now go to the backward pass operation. We take the 30 that we ended with and drop it down to the bottom right-hand corner in the final activity, and then we move backwards and start subtracting. 30 minus 2 is 28. So we take the 28, and since these 3 activities are connected, we put 28 at the end. Then we subtract again. If we go to the activity G, we have 28 minus 9 is 19. Okay, we have 28 minus 4 is 24. And we have 28 minus 6 is 22. Now you may wonder, well, wait a minute. The market ID, this is activity C, is connected to G. There's 19 here. Why isn't 19 in the bottom right-hand corner? Because this is a merge activity in the backward pass, and in a merge activity in the forward pass, you take the longest time. The merge activity in the backward pass, you take the shortest time. So 11 is shorter in duration than 19, so 19 goes in the bottom right-hand corner. 24 carries from F to D because there's only one activity connecting it. For activity B, you have 22 and you have 11 both connected to B, which is shorter. Remember, it's a merge activity in the backward pass direction. 11 is shorter, so you move that over. You have 11 minus 6 is 5, and 11 minus 5 is 6. We have both 6 and 5 merging. It's a backward pass, so we take the shorter value, and we have A. Now, you can use this, now that you're done, you can use this to determine which path is critical. And you do this by subtracting the top left-hand corner from the bottom left-hand corner. Or you could subtract the top right-hand corner from the bottom right-hand corner. It's the same, but we typically do it with the left. And anytime the left-hand corner and at the top is the same as the left-hand corner in the bottom, and you subtract them, the value you have in the center is a 0. So any activity that has 0 is a critical path activity. So we have activity A is a 0, C is a 0, let me back up, D is a 0, F is a 0, H is a 0. Now you may ask, why does a 0 indicate that an activity is on the critical path? 0 means there is no slack. There is no difference between the early start and the late start. They must occur at the same time. Well, if that's true, that means you cannot move that activity. So what happens if you do move the activity? You're going to delay the overall schedule. And if that's true, that means that activity is on the critical path. So we've used the forward and backward algorithm to find the critical path, and in this case it's A, C, D, F, and H. Now you could do some things to try and reduce the schedule overall duration. One idea is to use something called laddering. For example, you start with design of the first product, and then you start coding that one, and then while coding you do another design in parallel, and so on, and then you may shift to debugging. This is a way to try and do some more activities in parallel, perhaps that otherwise would not be in parallel. Another technique in scheduling is the hammock activity. We see A is in parallel with D, E, and F. The hammock activity is typically used with a series of activities that do not need to be managed. They just need to be captured on the schedule in some way. So one way to do this is to bundle them together. And when you do bundle them together, it's just generally referred to as a hammock activity. Okay, now when you reduce the critical path, what options do you have? You may try to eliminate activities if possible. You may take some paths that were designed to be one after another and put them in parallel. You could overlap sequential tasks. These are all things that you can do. But there's a word of warning here. Each of the things that you could do to reduce the duration of the schedule come with some risk and require some management expertise. If you try and do these things to reduce the schedule, you may ask yourself or ask senior management, if these could be done, why didn't we create the schedule this way in the beginning? Well, probably the reason was there was more risk involved and it was more costly to do so, so you didn't do it initially. But then maybe your schedule got into trouble and you used some of these techniques at a time when taking on additional risk was not so important. So there's some options. Okay, let's take another look at calculating the critical path. Here's an example, practical example of a business center development. And typically when you when you are asked to do a network diagram, you're given activities, descriptions, the predecessors, and the durations. Once you have the activities and the predecessor information, you can create the network diagram. You include the durations. At this point, you do not know the critical path, but you do the forward and backward pass algorithm to find out. And here, as you see, the difference between these two network diagrams. A, we would start with 0, we end with the duration of 5, and then B, C, and D would start with 5. Now going from B, C, D to merging into F, we've got 3 different activities. 20 is the longest. Merge activities on the forward pass, you take the longest. E has 15 and 20, so you take the longest duration activity because E is a merge activity between B and C. 30 carries over directly because there's only one activity connected, and then you have G and E. G ends with the longest duration, so the longest duration goes for the merge activity. Okay, then you come back with the backward pass, and we see, let's see, we have, let's take an example that could be a little complicated. B and C, it has F connected to it as well as E connected to it. F is 20, E is 185, because F is the shorter duration. In a backward pass merge activity, you take the shorter one in this case. Same applies for activity A. You have 5, 10, and 15. 5 is the shorter, and therefore that one moves over. Then once we have done that in the Coles Business Center, we can now look at each activity that has a 0 in it, and we see that A, B, F, G, and H have zeros. So because of this, we've identified the critical path of this project. Okay, so that's an example of how to calculate the critical path and how to determine slack. Okay, in this scenario that we just discussed, there's one thing that stands out, and that is each of the activities are assumed to be fixed in duration. For example, application approval is 5 days, traffic study 10 days, etc. Okay, and this is what you use when you're learning how to do schedules. But there is another approach that's called program evaluation and review technique. I'm going to show you briefly a scenario that uses this methodology, and the difference between PERT and the normal critical path method is that PERT assumes that each activity duration is not known with certainty, and therefore you apply statistical analysis. The good news is when you do this, it allows you to calculate the probability of achieving a schedule at a certain time, and we will have a problem like this on the final exam, but I'm going to show you quickly today, but we will go over this in more detail when I'm actually there. So let's take a look. Often PERT is used in helping executives understand the risk involved in a schedule. For example, your boss may ask you to take charge of a relocation project. It's typical. Many bosses have asked us to do similar things. An office relocation could be a project because it's temporary, unique, complex, uses resources. So we have to get started. You know already that when you start a project, you have a charter. You do stakeholder analysis, you determine the scope, you boil it down in the scope statement, you expand in the WBS. So the first thing you should do is ask your boss for charter. Okay, then once you have this, you develop a scope statement. For example, this is a scope statement of a relocation project, just a simple example. You have to know who's involved in the project, who has an interest in it, who's affected by it. What about the larger community? What do they think about it? Okay, now it's time to do the work breakdown structure. Notice that you see no verbs in this, only nouns. This is what the office relocation project is going to deliver. Okay, what's your next step? You identify activities, only those tasks that are required for producing the deliverables. So these are all verbs, and they're linked to this WBS. We first decide what we're going to do. Now we decide what is required in order to produce them. Then we take the activities and we put them in logical order. Now, in the previous example, we showed that the predecessors were given, so we could use this to create a network diagram. If you're an actual project manager, you're not going to be given this. You have to figure it out yourself. So you organize this in logical order. And let's say you do this and you assign durations to each of these. Now, once you've done this, you can do the forward and backward pass, and you determine the critical path. Activities 1, 2, 3, 4, 5, 6, 10, 11, 5, 12, etc. And you determine there's 130 days. Then you go to your boss, and the boss says, I want you to reduce the schedule. And you don't know what to do about this because you've used your best judgment to identify what the duration will be. So now that your boss says you should reduce this, you can use PERT to calculate the probability of actually delivering on time. And what you do is ask your boss to gather other executives, do a brainstorming meeting, and find the best case, worst case, and optimistic durations for each element of the schedule. This is a 3-point estimate. If you do the 3-point estimate, this allows you to use probabilities and use PERT analysis. So we gather the executives together, they each put their input in place, and then once this is done, we use a formula, and this formula is used in PERT. You take the best case estimate plus 4 times the most likely estimate plus the worst case estimate and divide that by 6. Why this formula? This is just a form of weighted average. It's used to incorporate the best and worst and most likely, with most likely weighted more. When you have this in place, your result is very similar to what it was before. You determine that you have 131 days duration of this project. But what do you do with these weighted averages? Since the weighted averages, the collection of these on the critical path, these are all weighted averages, so you're adding together averages. And when you sample a number of weighted averages, what you arrive at is a mean, which means that the duration based on 3-point estimates, since it is a mean, you only have a 50% probability of making that schedule. So all your bosses and executives, they've gotten together, they've given you estimates, but what resulted was simply a 50% probability schedule. That's like flipping a coin. And you can see this by taking a look at the normal curve. You look at the center of the curve, that's the mean, that's the 50% point. But what if you want to tell your boss about a 95% probability of success? You would have to go beyond the 50% mark and add to this. But if you're going to add days to this schedule, you have to think in terms of standard deviations. Because if you're going to go above 50% and up to 95%, you have to add a multiple of standard deviations, so you need to calculate the project standard deviation. And there's a way of looking at the normal curve and using ballpark methods to calculate the probability of area under the curve. And we'll discuss this in more detail when I'm actually there. But let's look at the project standard deviation. This seems complicated, but it's really simple. You find the variance of every task on the critical path, which is simply worst case minus best case estimate divided by 6 squared. Then you add the variances of each activity on the path, critical path, and then you take the square root of the sum of the variances. And that gives you the project standard deviation, because the standard deviation is the square root of the variance. Okay, so we now have an estimated duration is 131 days. The project standard deviation is 3.49 days. Okay, now the boss has already said you want to reduce this, but you already know that your boss and all of his direct reports have, with their best estimates, you've produced a schedule that only has a 50% probability. So this means if you reduce any time at all, the chances of you achieving this is going to be less than 50%. You don't need to reduce your schedule. You probably need to add to it in order to get that 95% probability. So we have a project estimated duration of 131 days and a standard deviation of 3.9 days. Okay, so the 131 days is at the 50% mark. We know this. The project SD, or standard deviation, is 3.49. Your boss wants to reduce this by 10 days. So what does that mean in terms of probability? If you reduce by 10 days, how many standard deviations of that? We know that one standard deviation is 3.49. So this means reducing project by 10 days takes you 2.86 standard deviations below the mean. Okay, and we know plus or minus 2 standard deviations is 95% area. So this means you're going to have a less than 2.5% chance of achieving that project schedule. But what about a 95% probability? That's roughly about 1.5. It's actually closer to 1.7. Okay, but this means you're going to be adding days. 1.5 or 1.7 times 3.49, let's say 137, 138 days. So instead of reducing by 10 days, you can now share with your boss, if I reduce this by 10 days, I've got almost no chance of achieving it. But instead, if I add about 6 to 8 days to it, I have a 95% chance of achieving it. So what do? You can use PERT to go to your boss and say, according to your own estimates, we only have a 2-point chance of achieving this. We'll certainly do our best to reduce the 10-day schedule. However, if you added time, we can actually do what you want and have a very good chance of doing it. Don't you wish you could say this? I think you would wish this. Now, if you don't absorb all of this all at once, that's understandable. Don't worry about it. We will go over it in much more detail face to face. But the lessons learned, using the program evaluation and review technique, allows you to calculate the probability of achieving a schedule. It can help you get agreement on the schedule, and you can be successful by using the very estimates of the management team that are pushing you for a reduced schedule. When you include their 3-point estimates, you can take the weighted average of those 3-point estimates for all activities on the critical path. And once you have those 3-point estimates and determine the critical path, what you have is a schedule that has a 50% chance of being achieved. And this is simply because that schedule is the sum of a number of means. The mean falls in the center of the normal curve. So you only have a 50-50 chance, the same chance of achieving that project as flipping a coin. If you go below the 50% level, if you try to reduce that schedule from that PERT estimate, you're going to drop the probability very rapidly, probability of achievement. So if your boss says, okay, these are estimates, I want you to reduce the time, the probability drops significantly, very quickly. What you really need is a 95% probability schedule. That means adding, about 1.5 standard deviations worth of project duration to your schedule. You can do this easily. Now, there is something known as a Z-table. I'm not going to show you the Z-table, but I will when we're there, when we're together. You can use a Z-table, or you can use the rule of thumb of the normal curve, that plus or minus 1 SD is 68%, plus or minus 2 is 95%, plus or minus 3 is 99%. You also may have heard of the term 6 sigma, which is used in quality control. 6 sigma means 6 standard deviations from the mean, which if plus or minus 3 is 99% of the area, plus or minus 6 is going to be not percentages, but parts per million. Okay, so you know that any PERT estimated schedule has a 50% probability of being achieved. You try to reduce a PERT schedule, you're going to arrive at dates that have a less than 50% chance of being achieved. Once you have done a PERT schedule, what you need to do is add about 1.5 standard deviations. And again, the exact number is about 1.7 standard deviations, maybe 1.68, something like that, in order to improve your chances. That is what PERT is all about. Now, as we've seen from this example, PERT and the critical path method look exactly the same in terms of a network diagram. And that's true. Often PERT and CPM, or the critical path method, they're used interchangeably, as I think I've mentioned before. And the reason is the tools that are used are basically the same. The only difference is that the PERT methodology uses 3-point estimates, and because 3-point estimates are used and a weighted average is taken, what you arrive at is a mean estimated time. And when you have that, using the normal curve, as we've seen, you can predict the probability of the schedule once you know 2 things: the project estimated duration, which is that mean, using the PERT estimates, and the project standard deviation, which is the square root of the sum of the variances. And the variances are simple to calculate. Worst case minus best case over 6 squared. Once you know that, you can plot it on a normal curve. So if you didn't get fully follow PERT, that's okay. We'll discuss this in more detail face to face. In the meantime, I look forward to being with you and discussing this in our next seminar in much more detail.